When you know all of the angles, it's really easy to show that two triangles are similar. But when you're dealing with the sides, it's a little bit harder because instead of showing equality, you're having to show proportionality. So in this case, if we're told that triangles ABC and DEF are similar, they are going to tell us the order of the similarity. So what I mean by that is that A and D, since they show up first, will be congruent angles. B and E, because they show up second, will be congruent. And finally, C and F will be congruent because they're the third listed letter. Then we can create proportions by connecting the sides that are supposed to be corresponding. So between A and C should be the corresponding side D to F. So we can make a proportion 6/4 from the large triangle to the smaller triangle. Then we can match up another set of sides. So I'm going to do AB, which is there between angle A and angle B, and the corresponding length on the smaller triangle is equal to 2 centimeters. So I have this proportion. I will cross multiply. So that would give me 12 equals 4 side AB. If I divide by 4, then side AB must equal 3. Then we do this again, and I recommend using the same starting ratio as you did for the other part. Since that one's given to you, there's no rounding, and it's easy to refer back to. But now let's make a ratio with the remaining side. Again, it's important that you have the starting triangle, whatever's on the top, needs to be on the top of the other half of the proportion. So we're going to go from B to C from the big triangle, and then the corresponding on the smaller triangle there is 3. So here I made big triangle over small triangle for each ratio. I could have done small to big as long as I had been consistent. So let's solve this again by cross multiplying. 18 equals 4 BC. Divide by 4, and that tells us that length BC is going to equal 4.5. And these are both in centimeters, so I should go ahead and put those units in there, because the units do matter. Now we have some practice problems here where we know that KN, which is that large length, is going to be 15. We know that MN is 9, MO is 12, and we're trying to find LM. So that's what we're missing. So how can we solve this? Well, here we know that these are given as similar triangles, and we're also given that entire length KN is 15. If we were told that MN is 9, then what would be left over to get to 15? Well, take 15, subtract 9, and that tells you that between K and M you have to have a length of 6 in order for us to get that total length of 15. Now we have this in mind, we can set up our proportion. It's just a matter of figuring out which sides correspond to which sides. So using the image here, that LM would correspond to OM. If you look at the triangles, if you look at the shape, those would be the sides that would be corresponding. So I can do my left triangle, that would be side X, over my right triangle, that would be side 12. Then go back to my left, I would make a 6 for my numerator and a 9 for the denominator. Cross multiply, 9x equals 72. Divide by 9, and that tells us that the length LM has to be 8. In question 2, we don't necessarily know automatically that these are similar triangles, but because AB is parallel to DE, we get those corresponding angles, and now we know that this has to be a similar triangle because the 3 angles are equal. So we can set up our proportions, but we do need to be careful here with how we set up our two triangles. It might help you to draw the big triangle separately so that you don't mistake that these links need to be from the small triangle to the big triangle. So here I'm going to just look at that big triangle ABC. And this whole length, BC, I don't know. I know that part of it's 6.5, but I don't know the rest. And then length AC, I'll find that by adding 3.5 and 5.25. So that gives me 8.75. So really, I'm just looking at these two triangles. So let's set up some proportions here. I know that we'll do the small triangle first. I know that I have 5.25 that corresponds to 8.75. And now I can set up any other proportion that I'd like. I can go from 6.50, and that corresponds to x. It's in the same spot. When I cross multiply and solve this, I end up getting that x is equal to about 10.83. Now x corresponds to the length BC, and so that tells us that the answer to C, the length BC, is 10.83. We did not directly solve for part B, where we needed to find the length BD. See, the length BD never showed up in a triangle. But if we know that the length from B to C is now 10.83, and we are given from D to C as 6.5, we just need to see what's left over. So 10.83 minus 6.5 will give us this length BD, which is 4.33. So notice sometimes you're not going to solve a problem in the order it's presented to you. We still need to find the length DE, and that is here on the small triangle. And I want to use that same 5.25 over 8.75. So I'm just going to erase. And so on my small triangle, this is what I want, so I'll call that Y. And then on the big triangle, the corresponding side is 10. So if we cross multiply and solve, we end up getting that Y is going to be exactly equal to 6, and that is DE, what we were trying to solve for.